Let's start this lesson by talking about the identity matrix. So the identity matrix is the matrix that has ones on what's called the main diagonal, which is from top left to bottom right, and zeros everywhere else. So to get a sense of why this is called the identity matrix, let's talk about additive identities and multiplicative identities. So this is not to do with matrices. This is, think back to Algebra 1. The additive identity is 0. So what that means is that if we take something like 6 and we add 0 to it, we get 6. So 6 plus 0 is 6. That means that 0 is the additive identity. So if you add 0 to something, that thing keeps its identity. It doesn't change. So adding 0 doesn't do anything. As far as the multiplicative identity, so this is the identity that has to do with multiplication, well, that's 1. So if we do 6 times 1, well, 6 times 1 is 6. So if we multiply by 1, the thing we multiply keeps its identity. All right, well, let's look at matrices on the bottom here. So what happens if we multiply, say, 3, negative 2, 5, 1 by this matrix that has 1s on the main diagonal? Well, this is a 2 by 2 times a 2 by 2. So we can multiply these since the number of columns in the first one matches the number of rows in the second one. And then it'll take on the dimensions of the outsides there, the rows of the first one, columns of the second one. All right, so we're going to end up with a 2 by 2 matrix. So let's look at the top left spot. So the top left spot is in the top row left column. So let's multiply 3 and negative 2 by this column here. So starting in the first spot of each, 3 times 1 is 3. Then negative 2 times 0 is 0. So we get 3 plus 0. Then for the top, top right spot, we're going to use the top row right column. So that's 3 times 0 is 0, plus negative 2 times 1 is negative 2. And then, for the bottom left spot, that's going to use the bottom row left column. So that's 5 times 1 is 5, plus 0 times 1 is 0. And then for the last spot, we've got bottom row right column. So that's 5 times 0 is 0, 1 times 1 is 1. All right, if we simplify everything in that matrix there, 3 plus 0 is 3, 0 plus negative 2 is negative 2, 5 plus 0 is 5, 0 plus 1 is 1. And look at that, we get back the exact same matrix. So between here and here, nothing changed. So when we multiply by that matrix, we get back the original matrix. So that's why this is the identity matrix. When you multiply by the identity matrix, the thing you multiplied keeps its identity. It doesn't change. All right, again, let's go back to additive identity and multiplicative identity. So let's actually start talking about inverses, though. So if we look at what the additive inverse of 12 is, so this is the thing we would have to add to 12 to get rid of 12. So that's going to be negative 12. So if you add 12 and negative 12, you add those together, you get 0. You get the additive identity. So combining something with its inverse gives you the identity. So 12 and negative 12, these are additive inverses. And if you combine 12 and negative 12, you get 0. Well, the multiplicative inverse, that's going to be the thing that we have to combine with 12 to get the multiplicative identity. So what do you have to combine with 12 in terms of multiplication in order to get 1? Well, think about 12 divided by 12. 12 divided by 12 is 1. So if we think of that in terms of multiplication, that's just going to be multiplying by 1 over 12. So multiplying by 1 over 12 is exactly the same thing as dividing by 12. No difference there. So 1/12 times 12, that's 1. So if we multiply 12 by 1 over 12, that's its multiplicative inverse. So if we combine those together with multiplication, we get the multiplicative identity. So the inverse of a matrix then would be the matrix that you would have to multiply by, say, if we took matrix A, maybe we take the same matrix that we had last time. I guess I don't remember what all the exact numbers were, but say we take that matrix. If we multiply that matrix by something, so So I'm just going to leave it blank. Say we multiply it by something. I don't know what that thing is. And we get the identity matrix. Oh, whoops. That should have zeros here and here. So we multiply that by something. We take matrix A, 5, negative 2, 1, 3. Multiply it by something. We get the identity. That thing that we multiplied by would be the inverse. All right, let's look at how to find the inverse of a matrix. So this right here is the formula. So we have matrix A with A, B, C, and D inside of it. And to get the inverse matrix, we're going to follow this formula in the box. Now, first of all, this thing in front here, 1 over, and then that kind of looks like absolute value. If you don't remember, that means the determinant. In the context of matrices, that means the determinant of the matrix. So let's find the determinant of the matrix first. So if you don't remember from 3.7 how to find the determinant of a matrix, you might want to run back and look at that. Oops, that should be minus. 3 times 5 minus 2 times 8, that's how we get the determinant of this matrix. So that's 15 minus 16, which is negative 1. All right, so we're going to do 1 divided by the determinant of A, and that's a scalar out front of this matrix where we switch the downward diagonal. So we're going to take the 3 and 5 and switch them around. And then we make negative, or I guess switch the sign of the other two. So this is going to become negative 2 and negative 8. Now let's multiply through by that scalar. So 1 over negative 1, that's really just negative 1. So we're just going to take this matrix and multiply everything in it by negative 1. So that'll give negative 5, positive 8, positive 2, and negative 3. So at the bottom here, that is the inverse of A. Now, just to be sure, let's actually check this and make sure that it really is the inverse. So that means that if we multiply these two things together, we should get the identity matrix. So let's do just that. All right, for the top left spot, we're going to do top row left column. So that's 3 times 5 is negative 15. Then 8 times 2 is 16. For the top right spot, we're going to use the top row right column. So that's 3 times 8 is 24. 8 times negative 3 is negative 24. And then for, let's see, the bottom right spot, we're going to use the bottom row, bottom left spot, we're going to use the bottom row left column. So that's 2 times negative 5 is negative 10, plus 5 times 2 is 10. And then for the bottom right spot, we're going to use the bottom row right column. So that's 8 times 2 is 16. And then 5 times 3 is negative 15. All right, combine this all together. So on the top left spot, negative 15 plus 16 is 1. Top right, 24 minus 24 is 0. Bottom left, negative 10 plus 10 is 0. And bottom right, 16 minus 15 is 1. So we get back the identity. So that tells us that that really is the inverse, because if you multiply something by its inverse, you should get back the identity. All right, now let's look at how to solve an equation with matrices. So this is where it gets really tricky. But it's good, again, to think about things that are not matrices and try to translate that into matrices. So before we even look at how to solve a matrix equation, let's just say that we have an equation like 2 times x equals 8. And we want to solve that for x, solve for the unknown. So what do? Well, obviously we divide by 2, right? So we have 2 times x, so what we want to do is divide by 2 to get rid of that. Well, again, let's think of this with inverses. So if we instead think of dividing by 2, let's think about multiplying by its inverse. So to get rid of 2, if we have 2 attached to the x there, to get rid of 2, we have to combine it with its inverse. So the inverse of 2 is 1/2. If we multiply both sides of this equation by 1/2, it's the exact same thing as dividing by 2. But it's good to think of it this way because we need to think about inverses here. So if we multiply both sides of the equation by the inverse of what's attached to x, which in this case is 2, we multiply both sides by 1/2, then 2 times its inverse, 2 times 1/2 is the identity, that's 1. So we get 1 times x. And then on the right side, we just have whatever was on the right side times the inverse, which in this case is going to be 4. So we get 1x equals 4. Well, 1x is really just x, so that's really just x equals 4. Well, that's exactly what we're going to do with a matrix equation, except instead of using numbers, we're going to use matrices. So say we start with the equation ax equals b, where a is a matrix, x is a matrix that we don't know, it's an unknown matrix, and then b is another matrix. So what we need to do is, just like how if we have 2 times x equals 8, we need to find the inverse of 2. Well, if we have a times x equals b, we need to find the inverse of a. So you find the inverse of that first matrix and multiply both sides of the equation by that inverse. Well, then on the left side, when you multiply something by its inverse, you get the identity, which is the matrix version of 1. And then on the right side, you just have the inverse of a times b. Well, again, the identity matrix times x is really just x. So when you have, just like over here, 1 times x is really just x. The identity times x is just x. And then, so what you're left with, the solution to the equation is the inverse of matrix A times b. Just like over here, the inverse of 2, which is 1/2, times 8 is equal to x. Let's give this a try. So, we have matrix A right here, times x, the unknown matrix, equals matrix B. So to solve this equation, what we need to do is find the inverse of A, and then multiply that to both sides of the equation. Now it's very, very important when you are doing this to remember, and I should have mentioned this on the last slide, that it matters what order you multiply matrices in. So if you multiply a matrix on the left side of another matrix versus on the right side of another matrix, you will get different answers. So that's not the case with normal multiplication. So think about like 2 times 5, that's 10. Or if you do 5 times 2, oops, 5 times 2, that is also 10. Not the case with matrices. So if you have one matrix times another matrix and you multiply those out and get an answer, and then you take those two matrices and switch them around and then multiply them again, you will get a different answer. It really does matter which order you multiply matrices in. So when you're solving a matrix equation, it's very important that you always multiply your inverse on the left side of each side of the equation. So since over here we multiplied A inverse on the left side to get rid of A, we've got to multiply on the right side, we've got to multiply A inverse on the left side of B, not on the right side of B. If you multiply A inverse on the right side of B, you will get the wrong answer. Okay, so we need to find the inverse of matrix A. So first of all, we need, for the inverse, we need 1 over the determinant. Well, for the determinant, that's going to be 2 times 4 is 8. Then negative 1 times negative 7 is positive 7. So then we subtract 7. And then multiply that by, so we switch the main diagonal, 4 and 2, and then switch the signs of the others. So that's going to become positive 1 and positive 7. So again, this is for the inverse. So A inverse. All right, 8 minus 7 is 1, so we get 1 over 1. So basically the scalar here is really just 1. So the inverse matrix is 4 times 7, 4, 7, 1, 2. That is the inverse. So if we take that original equation, which is this, 2, negative 7, negative 1, 4, times the matrix X, which we don't know, and then negative 21, 3, 12, and negative 2. We take this and multiply both sides by the inverse of A. Make sure to do it on the left side of each side of the equation. Oops. Then on the left side of the equation, this part boxed in red, well, that's a matrix times its inverse, so that will turn out to be the identity matrix. You're welcome to multiply that out and see that you will get the identity matrix, but I'm not going to take the time for that. So we get the identity times x equals, And then on the right side, we just have to multiply this out. So for the top left spot, we have 4 times negative 21. So that's negative 84. And then plus, so we go across the row down the column. I'll skip over this. If you need a refresher on matrix multiplication, go back and look at 3.6. All right, so we're going to start back up at the top here. So we have the identity times x on the bottom, which is really just x. And then to get the resulting matrix, again, I did the work here for multiplying the matrices in the bottom right, so we just combine those together. Negative 84 plus 84 is 0. 12 plus negative 14 is negative 2. Negative 21 plus 24 is 3. 3 plus negative 4 is negative 1. So that is the solution to this system of, to this matrix equation. So if you were to take this red matrix up top here and insert it into this equation for x, so if you were to multiply this matrix by x that we found, you would get that matrix on the right side. If you would like to check that, you're welcome to check that.